my parents after the game were putting up on Discord, like saying,
This leopard was so disrespectful.
People from art?
no, it's guitar. I don't know. Everyone's got that. Yeah.
Oh my god.
Act like, oh my
They're
god.
just mad they lost. That's just clown talk. They're mad they lost.
Okay. So we're gonna do a little section here, really quickly. And then if we finish before lunch, we'll start reviewing, but we'll definitely review after lunch, okay? So get your notes out and your calculators. We are going to be drawing some things on our calculators. Sketching on our calculators.
Is this EP Precal?
Yeah.
It's the same stuff.
Some things that you,
We do the units.
Yeah, you're right.
we're going to be sketching some things on the calculator that would be very, very hard to sketch regularly by hand. We have done some sketching of sines and cosines. That's not hard. But if you look in your notes, 4.6, wait, have we finished? Did we do number 2?
Yeah.
You did?
On page 46?
Yeah, we finished that.
Yeah, we that? Okay. I didn't make a note of it, so I wasn't sure. All right, so if you look, question A, 1A says we're going to sketch sine x squared. All right? Now, before we start, I want you to go to mode and be in radians. This is fourth. How do I know I'm in radians? Look at the directions of the problem. It says negative 2 pi to positive 2 pi. That means we're going revolutions in radians, right? If we were in degrees, it would say negative 360 to 360. So make sure radians is highlighted. Oops, radians is highlighted. Then go to window. I forgot where it was, it's where I'm pointing. And your x's, x min is negative 2 pi, and use the pi button. You don't know where it is, look where I'm pointing. That's your pi button. And then x max is positive 2 pi. Okay, now you can just leave the scales at 1, so x scale is just 1. And then where it says y min and y max, let's start with negative 1.5 and positive 1.5. Very small little window. All right, so we're negative 2 pi, negative 1.5, 1.5. All right, now go to y equals. We're going to put in our equation. So parentheses, sine x, and remember your variable where I'm pointing, that's your variable. And then you got to close the parentheses around the x, close the parentheses you put in, and then square it. And hit graph.
What was your window again?
Negative 2 pi to 2 pi, negative 1.5 to 1.5. Now, does it look kind of like a sine curve? But notice that there's no valleys. It's all hills. Anybody have an idea why it's all hills? Because we squared it. And when you square something, what happens? It becomes positive. So it's just, okay? And you don't need to answer any questions about it. We're just graphing it.
Just draw it.
Okay, yep, we're just drawing it. So just do a quick little sketch there. And remember, when you label your x-axis, it's negative 2 pi to 2 pi. That's how you set it up. Okay. Now, let's try B. We may have to make a window adjustment, but let's leave everything the same and try equation B. You got something, we're going to make a window adjustment, which would you change your window, leave the negative 1.5, but make the Y max like 50? I don't think it changed much, did it? I thought I was gonna see more, but I don't. So that's just it, graph it. Graph whatever you see. And label your axes. That's what we would do, is label our axes. I'm changing my window and I'm really not seeing much.
What'd you change?
Do you see a parabola coming, change it to whatever you want. Do you see a parabola coming down? And then it's kind of heading off into quadrant 1? Any idea why it's just kind of going like this into quadrant 1? Well, first of all, what does x squared look like? That's a parabola, so you're kind of getting it's altered, but it's kind of parabola-ish.
Yeah.
And then you're adding 2 sine x, and sine x is between negative 1 and 1. It just goes back and forth. So you're like adding 2 basically, and so it's just kind of lifting that parabola right off into quadrant 2, or 1. All right. When you put, now we're going to go to number 2. So number 1, real easy. We just practice typing some stuff in our calculator. Whatever we see, we see. I'm never going to ask you about those equations. You just need to know how to type in stuff on your calculator. Now, equation 2, here there's something to know. Is it a sinusoid? Why or why not? And what is its period? Now, when you start combining true functions, a sinusoid is something that has a sine shape. So a cosine is a sinusoid because it has a sine shape. Shift it over, but it's the same shape. To tell if something will be sinusoidal or not, look at each piece, okay? So, sine, I'm looking at problem A, sine. What is the period of that piece? What's the period of a sine?
2 pi.
2 pi. Okay, there we go. What's the period of this piece?
2 pi.
When the periods match, they do not have to be 2 pi. They are here, but they can be anything. When they match, you're going to get a sinusoidal shape. So, first question says, is it a sinusoid? Yes. Why? Because they both have the same period. What is that period? 2 pi. So we just answered all 3 questions. All right, let's look at B. What is the period of the first part of the problem?
2 pi.
2 pi. What is the period of the second part of the problem? Pi. Is it a sinusoid?
No.
No. Why not? The periods of each individual piece are not the same. Okay? But here's the thing. Both of these are periodic. This is a periodic thing and this is a periodic thing. When you add 2 periodic things, you're going to get a periodic thing. So it's not a sinusoid. Its shape will not be a sine curve, but it is periodic. And here's how you find the period. So let me back up, make sure everybody's clear on that. It's not sinusoidal. Everybody okay with that? Because these aren't the same. However, it is periodic. So the period of the first piece is 2 pi. And what that means is every 2 pi, it repeats. So it starts over again. So we got 0 over there. Starts over again at 2 pi, then at 4 pi, then at 6 pi, and so on. Agreed? Now this one starts at 0, and then starts over again at pi, 2 pi, 3 pi, and so on. The first time after 0 that they repeat, the first time they overlap, is their period. So what is the first number that both rows have? So the period of this is 2 pi. It is not sinusoidal. It won't look like a sine curve when you graph it, but it will repeat every 2 pi units. All right, how about C? What's the period of the first part?
2 pi, 2 pi.
No. That divides your period, remember?
Oh.
So it's 2 pi over 2, which is pi. And then what about 3 sine 5x? 5x.
2
That's going to be 2 pi divided by 5. Everybody okay with that?
Yeah.
So the period of the first piece is pi. This is 2 pi over 5. Not sinusoidal because they don't match. But what will the period be? Don't be careful. Pi, 2 pi, 3 pi, 4 pi. And as many as you want to go. That's these, right? Then this one will be 2 pi over 5, 4 pi over 5, 6 pi over 5, 8 pi over 5. Are you following what I'm doing? 10 pi over 5. Stop. What's 10 pi over 5? There I got a match, right? That's my first match. The period will not always be 2 pi. It often is, but it won't always be. What you have to do is look at each individual period, and the first time they both start over at the same place. So this is starting over at 2 pi, this is starting over at 2 pi. That is the period. Okay, so you try D. Try D. Do not be confused one bit about the pi out in front, because the only number you care about is the one on X, right? That's the one that matters. So, see if you can figure out whether it's sinusoidal, explain your answer, and then find the period. Did you get 2 pi is the period again?
Oh, yeah.
Yeah.
It loves 2 pi.
All right, look at E. What is the period of the first part of E? 1. Isn't it 1? How do we find period? 2 pi divided by that coefficient. What's the period of the second one? 1. So it's sinusoidal, and its period is 1. For F, again, don't get confused. When we're talking period, what is the only thing we worry about? The coefficient on X, right? So what is the period of the first part? Pi, 2 pi divided by 2? What is the period of the second part? 2 pi over 3? I think we already
Which one would go for
run F.
Oh, I was looking at E.
No, E, they both have a period of 1.
Yeah.
So F, we have pi and 2 pi over 3. Didn't we have that one already?
Yeah.
And it was 2 pi again? I know you're thinking it's always 2 pi. Oh, it isn't. Just so happens the things I wrote down, it is.
Wow.
I know. Wow. All right? So that's enough, we'll start reviewing. This homework, 4-6, that's it for 4-6, so that'll be due on Friday. So make a note of that.
What is the period for y equals 3 cosine 2 cosine
What, 2 pi
divided
divided by the coefficient on x.
what was the coefficient for that?
It's the number hooked to x, like 2x.
Yeah.
Yeah, you're gonna, if I were graphing it, I would move it outside, yeah. But I don't need to for this question. But, oh yeah, I'm gonna read that one. So if I were graphing it, I would. Okay, so let's get out. I had given you a review sheet, or it was something, it was an old quiz or something. A Requiz. And we had already done the first 2. So here is a perfect example of what we were just talking about. If I only cared about the period, I could leave my problem just like this and tell you that the period is 2 pi divided by 2, 4 pi, that's my period. Which means my frequency is going to be 1 over pi. Fortunately or unfortunately, however you look at it, I am going to have to graph this thing. So that is not in good shape to graph. So to graph it, I'm going to pull that 2 out of the parentheses. That is not impacting the period. I've already figured out what the period is. It's just going to help me figure out where to start my picture. When I take that 2 out, I'm going to be left with x minus what? Pi over 8. Now, some of you were very tentative with that. Check it. What is 2 times 1/8? Is it 1/4? Good, you got the right answer. Now I'm ready to graph it. Alright? So I know it starts at positive pi over 8. There is no vertical shift up and down, no number out here, so I don't need to worry about that. It's positive, so it's going to have a regular old sine shape. Would you agree with that? Only it's starting at pi over 8. It's going to go up 3 and down 3. That's its amplitude. And now I have to find these labels. Now you will do that however you want. For me, it's usually easiest to find the last one first, because I know the period is pi. So I'm starting at an 1/8, and I'm moving a whole pi. So what is 1/8 plus 1? 9/8. 1 and an 1/8, or 9/8. And then I need to know what's right in the middle. So this is 1 and 9 makes 10, and half is 5. And 1 and 5 makes 6, and half is 3. And 5 and 9 is 14, so half is 7. Phase shift, PS is phase shift. That's positive pi over 8. That's where we started the picture. You okay with that? Alright, now we're going to find the exact value of the tangent of 3 pi over 4. So I can figure out what that is in degrees. That would be 135. Check my arithmetic there. 135. Where is 135?
22.
Quadrant 2, there's 135. What angle is right there? 45? 135 to 180? Remember guys, if you're doing this without a calculator, it's a 30, a 60, or a 45, right? Every time. Otherwise you need a calculator. Till chapter 5, then we'll figure out some others, but right now that's all we can do. So 45, that's gonna be a 1, 1, and a root 2. That one is negative, yep. Not in quadrant 1, so we know we got a negative. We want the tangent. Tangent is opposite over adjacent, so the answer is negative 1. Now we got a really easy one. We're sketching a tangent, okay? What does y equal 10x look like?
The wavy line,
Well, it has an asymptote
It's like a.
and an asymptote, and it curves up through the origin like that. What are my labels? There's no change, this is just a regular
eye
tangent.
on the right.
Zero.
So negative pi over 2, positive pi over 2. Whoopsie, if we've forgotten our basic curves, we need to get that learned. That is not on your cheat sheet. Alright, what's my amplitude?
None.
None. Yeah, so 0 slash 3, none. What's my period? Pi? Yep, pi. What's my phase shift? None, we didn't move it. There's nothing added or subtracted. So there's no, so you write 0. The phase shift is 0.
Slash.
The no, 0. The vertical shift is also 0, because there's like a plus 0. And then the frequency would be 1 divided by pi. All right, number 6. Given secant is negative 5/3, find all the rest of them. All right, so we're finding all of this. Secant is negative 5/3.
Quadrant 2 or quadrant
No, if secant is negative 5/3, then cosine has to be negative 3/5. That is right. Now, what are they telling me? They're in that little inequality. What is that saying?
It's in between the degrees, in between
It's
180.
in between, so here's my setup. It's in between 180 and 270. So this is gonna be my picture. And cosine is adjacent over hypotenuse. The hypotenuse will never be negative, right? No negatives on the hypotenuse, ever. Now we'll do the Pythagorean theorem. I forgot to say, who are we missing besides Alexi? Anybody? Jaden. Missing Jaden. And Alexi. All right, what did you get for your opposite side here? Negative 4? Did you put a negative on it? It's not a
16.
negative.
25 minutes.
So in that fraction, the 5's negative, so we just forget about the negative because the hypotenuse can't be negative.
No, when you have a negative fraction, the negative can go on the top or the
Oh,
bottom. And in this case, it has to go with 3 because it can't go with 5. All right, everybody okay with that picture? Remember when you do the Pythagorean theorem, A and B are here and that is C, always, always, always. All right, answer the questions. What's the sign?
Negative 4/5.
Negative 4/5. Tangent,
4/3.
4/3. Cosecant,
Negative 5.
negative 5/4. And cotangent, 3/4. Okay? Now we still have 5 more minutes. I made a list of some more problems I want to do. And during lunch, I will find another paper and we'll figure that another one out. But I do have a couple more problems I want to do. So here is one of them. Somebody is riding or walking or something, or I guess they're driving, and they go 10 miles in 7 minutes. The diameter of their tires, I'm not writing out the whole problem, but I'm moving, riding a bike, go-kart, something. I go 10 miles in 7 minutes. The diameter of my wheels is, let's say, 25 inches. The diameter of my wheels is 25 inches. I want to know revolutions per minute, otherwise known as RPMs, okay? So this is what I know. I go 10 miles in 7 minutes on a vehicle that has tires that are 25 inches in diameter, and I want to know how many revolutions per minute are my tires there. Okay, so you know what this is going to be, right? So I'm going to start with what I know, which is right here, 10 miles, 7 minutes. Would you agree with that?
Yeah.
And somehow I got to get from there to revolutions per minute. Well, this is awesome. I'm good with my minutes. I just have to get from miles to revolutions. I always tell you, and I think it's important, start with that revolution. We know that one revolution is a circumference. One revolution is a circumference. So, one revolution is a circumference. And what is the circumference if the diameter is 25?
55. Oh, no, 25 miles.
Circumference is 2 pi r. Isn't this 2 r's right
Yeah,
here?
so it's 25
So
miles.
it's 25 pi. And the unit on that is inches. You gotta get revolutions into your problem. A revolution is a circumference, okay? Now, everything's great. I got revolutions and I got minutes. The problem is I got all these other units running around, so I have to get rid of them. So 12 inches, 1 foot, 5,280 feet, 1 mile. Is everything gone now? Right? So I'm going to type in 10 times 12 times 5,280 divided by 7 divided by 25 pi in parentheses, or do them separately. Divided by, that's it. Wow. I got 1152.46. Anybody else get that? 10, 12, 5,280, yep, divided by 7, divided by 25, yep, that's
I
it.
got 11 loops.
You got what?
11.
Oh, that's the radians one.
You should have gotten the this.
I got that.
All right, yep, go on, I'll see you back here at 12:30. 12:30, in your seats, ready to go. Jay Gardner, was your phone in the door? Oh, dude, bad news.
Just forward. Can you move your head for a second?
Gotta see who else is trying to cheat the system. Not Pat and Rock. No, you're good. Your phone in the pocket?
Yeah.
It's in your pocket too?
Yeah.
Okay, dude. Where's it supposed to be? Absolutely.
It's that table back there.
I know. And they're good kids. I don't understand it.
They're conspiring.
Let's get both of them. All right, I know, this is so not conducive to you.
It's
You
okay.
wanna sit in a different place? Why don't you, I mean, you're welcome to sit in a different place, like,
Okay.
you can sit in the, is someone sitting there, or that you just?
I think you just put his stuff there.
You can sit there, so you don't have to
Okay.
navigate the cereal.
Okay.